Hello and welcome to TidyX episode 132. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. This is TidyX. As always, if you like and subscribe on that YouTube channel, we'll be able to get back to you on any questions, comments, answers, problems that you might be dealing with. As always, we love doing this, and we appreciate all the support that we've gotten through 132 episodes. If you feel like we've impacted you in a positive way and you want to donate to us, we do have a Patreon page, and we're always thankful for anything that anyone gives.
Very grateful.
That said, we're going to jump into episode 132. Ellis is going to set up the problem statement, and we've been, just as an aside, we've been working with over the past like 4 or 5 episodes with sort of shiny and interactive, Plotly, our Markdown interactive type of reports. I think based on the YouTube comments, this has been a pretty popular topic, and people have been commenting and enjoying it, using it in their own work. So we're probably going to jam on this for a bit. Let's jump into this week's Shiny episode.
Yeah, for sure. Yeah, so Shiny is an R package within R that allows you to create really great interactive web pages. The value of that being you can multiply your impact, right? So rather than you having to write all these scripts and every time somebody has a new question, if there's a thing that you get asked a lot about and it's just a simple matter of going out to the database or whatever source of truth it is, pulling that in, running the same code on it every single time, and in giving them the answer, whether it's a plot, whether it's an updated data set, Shiny is incredibly helpful for that. So what I thought we might do is we might build a simple Shiny app to talk or to allow us to do what we talked about in episode 127, which was fuzzy matching, and allow our users that aren't programmers to also do fuzzy matching on player names. Because I think as we put it in episode 127, sometimes people's names get really messed up or they're inconsistently labeled across different data sources. And so the idea is that this will allow you to hand this off to your non-programmer team, and they can upload the CSV, upload the preferred names that you have in your database, boom, and get out the matched names that your team or your organization uses. So let's quickly set this up real quick. So we're going to use library Shiny to make our Shiny app, Tidyverse for all our data manipulation needs, and DT is going to be used later in the Shiny to make a nice table for us. And then if you'd like to learn more about exactly how the fuzzy matching works, we're using the agrep function, and you should watch episode 127. The link will be up above there to learn more about how exactly that works. But Patrick, do you want to take us through the UI?
All right, jumping into the UI. So remember, Shiny apps, we always have a UI and a server. The UI is what is the user specifying what they'd like, and then the server does all the heavy lifting and returns back to them what they want or what they've selected. So we're going to start with a UI. We've got a fluid page here, and we've got a little title panel. The title panel is just going to say fuzzy matching up at the top. And we're going to have a two-column UI. So remember in Shiny that the page, for whatever reason, there's probably a good reason why, and I don't know why, it's broken up into 12ths. The columns are in 12ths. So however you slice it is going to be how big you want each column to be. So in our case, we have 2 columns. One is a width of 4 and one is a width of 8. And that makes 12. If we were to go over that, it would just bark an error at us that it can't go over 12. In the left-hand column, and in our previous Shiny apps, we used to do sidebar. We've done sidebar panel with this. This time, we're just going to set up the columns of the page. We have the left-hand column is a width of 4, and it has 2 inputs that the user can specify. The first input is it's going to allow the user to upload a raw CSV file of the names that they need to get their matching for. The second input is the reference file. So the reference file is what is a text file that the user believes are the names that they, their gold standard names, we'll call them, the names that they want them to be within their data set, within their database. These are the key names that are the primary key for all the other tables that they're trying to match their data to. So basically it looks like this. We have a CSV file that has maybe scraped some web data from some soccer teams, and we've got like information about the player, the team, and some like little performance markers, some objective measure, and the user has this reference name text, which is basically first name space last name and then space if there's any sort of suffix to the end of their name, obviously. So all it is for the non-programming audience, these are literally click browse, upload from wherever it is on your computer, and then click browse, upload from wherever the reference names are on your computer. You're pretty much ready to go. The right-hand panel is going to be the output that the server is going to spit back out at you. So again, this is a column of width of 8 because we already burned up 4 in our left-hand panel. So we've got 12 to go. So 8 is the next one. We're going to say this UI output is we pass it this argument call select UI. That's going to be what takes place. The kind of the heavy lifting is that takes place down below in the server that Ellis is about to walk through. We've got a DT data table output. So Ellis is directly calling the DT package here, and then he gives the 2 little colons, and he says, this is the exact function I want from that DT package, and it's the data table output. That's the output that works within Shiny that says, hey, server, get me a data table, and that data table is going to be called fuzzy match preview. So when we do an output in the server, we're going to use that direct call to fuzzy match preview because we're going to say this is where we want the output to go. And then the other UI output that we have here is download UI. So once the person gets the data table returned back to them, we figure, hey, you might want to download this, upload it to some sort of database so that you can do your work. There's your option right there. It's going to be a little button, and you click download, and it gets spit back out to you. That's a little bit about the UI. If you have ideas or other things you'd like to see, remember, like and subscribe on the YouTube channel. You can drop it below. Ellis is going to take us through the server.
For sure. Yeah, the UI output allows us to do some programmatic pieces later on. So that's why they're left just as UI outputs. That's just a generic, there's going to be something here, but I'm not defining it in the UI or in the UI fluid page up here.
Right. As opposed to like a plot output or a table output or something
defining
like that, which is explicit.
There. Yeah. Yep, exactly. So now we're getting into the server. So the server is a function. It accepts 2, potentially 3 inputs. So there's the input, output, and then sometimes there's the session. We're not needing session in any of our functions, so we don't add it into the server function argument list. So the way that I like to organize my server function is I like to kind of think about it linearly. So at the very top, I like to do what are the things that I'm expecting the user to interact with first. And so in this situation, in this Shiny app, we're going to be asking them to upload the files. Right? Before they can do anything in the Shiny app, we need to know what they're giving us. And so we have these 2 reactives, the raw dat and ref-vec reactives. They both will take the results of the file input pieces from the UI, so the file input up here. And we'll do some checking to make sure that they are uploading the correct file format. And so in this case, for the CSV file, we want to make sure that they actually uploaded a CSV. And then if it doesn't, it's going to go, hey, like you didn't upload a CSV, please fix that. Then for the text file, similar idea. We take the ref file. We're going to check that the data path that they provided is actually ends in .txt, and if it doesn't, they're gonna go, hey, please upload a text file. Then we actually read in the files because they actually uploaded the data to us. And so for the CSV, we use the read_CSV function from readr, and then we use the read lines function, which is from baseR. And I added this warn equals false because it'll complain to us if you don't have a new empty blank line at the very end. I don't really care about that, making our users have to do that. So I just turn off that warning. And so now we have our data. We have the CSV in raw dat, and we have the vector of uploaded known to be correct names for our database.
And so, as a quick aside, we have that as a text file, but if you store yours as a CSV, you could simply change that validate line to the exact line as line 63, and you could say, please upload a CSV file, and that's it. And so you could change those if you wanted. Part of it was just to show the options that you have with different file types, but it doesn't have to be a text file.
Yep, exactly. So now we're going to get into our first render UI situation. So we have that UI output in our UI. So this piece is going to now update that section of the UI with more UI. And so in this situation, what we wanted to have here was two buttons to appear, but only after the user has uploaded the CSV. So that's why we have this rec raw dat. So this is going to prevent this entire statement from running until raw dat is no longer null. Once it's no longer null, the rest of this can run. And so that's a nice thing to kind of throw into your functions if you don't want it to try to run and be going, hey, I don't know what to do with this null value is. Throw a rec in there and it's going to stop it running. We're going to use a tag list. You can also use a list. Basically, this is just creating a list of the different UI elements that you're going to be adding here. And we're going to have a select input and a numeric input. So this select input is going to have the input ID of raw file call names, and the label is please select column to fuzzy match to. That's because we need to know what column we're actually trying to match to. It's a CSV. There's in theory multiple columns that you're providing to the server. It doesn't know what column by default that you're wanting to be using to match your reference names to. And so then we're going to give them the choices of any of the column names inside of raw dat. And by putting it inside of this render UI, anytime they upload a new raw dat, this whole UI is going to update to represent the new column names that they've uploaded. And so this kind of allows you to constantly be updating. The other way you could do this is using select input update. I believe that's the function. But it just gets more complicated. I like this approach. And then we're going to have a numeric input. And so this is just going to be a bar with a number, and you can tick up or tick down. And this is going to have the input ID of fuzzy match distance. So this is what we need to pass to our fuzzy matching function to tell us what is the distance that we're allowing between the reference name and the name that it's matching to see if they are close enough to use that real name. And then I have the label fuzzy matching distance, and then the guidance to see the agrep max.distance function or argument to learn more about what this function actually, or the distance actually does. I set a minimum value, a maximum value, the value I wanted to start at, and the step. So there's going to be two buttons where you can click up and down. This is how much it's going to step. Of course, you can write in your own number, but this is going to just kind of help with some of the ticking up and down. Now that we have all of that input, we have the CSV uploaded, we have the reference file, and we know the column we want to be matching on, and we know the distance. Now we can actually perform our fuzzy matching. So I'm going to throw that inside of a reactive. We're going to have these recs here to protect this function from trying to run before we have all this information already set. We're going to take raw dat and convert it from a reactive into the actual data frame that it actually is. We're going to pull out the column name. So we have the .df or data frame. Then we're going to pull out the column name as defined through that input select input function and set that to be the raw vec. And we're going to use the get preferred name function, which is the function we wrote in episode 127. We're going to use the reference vector, or excuse me, the raw vector, the reference vector, so the names that we want to be using, and then the input match dist. So this is how far are we going to let them to be off in order to match the name to it, and this is now going to give us a preferred names vector. That was from chatting earlier. So now we're going to use this add column function. So the add column function is from the Tibble package, and it has some nice features. Basically, it allowed me to very easily add in this new column exactly where I wanted it to. Of course, we could have done dat $, new call name, or preferred names, and drop in the preferred names vector. But this allowed me to do a couple things. First, we're going to say add column. The data we're going to be using is dat. And then this piece this line is saying set the column name to be paste 0 of the input name that they selected and add an underscore ref to it. So it'll be like names underscore ref, or player names or player underscore ref. And then use the values to be using are the preferred names that we have. Then I want you to be placing that right after the input column name. So name or player, whatever that actual input is, so that they appear next to each other. And I think this makes it a little bit easier to see and understand what's going on in your data. We're going to assign that back to dat, so we're overriding dat with the data frame with the updated column, and then we're going to turn that to the reactive there. Now we can go and preview the results. So we're going to add that. We're going to use the DT render data table. Earlier we had the DT data table output, and this is just going to be a very simple data table where we're going to take the match data, pipe it into the into a data table, and preview it that way. Finally, we have the download handler. So the download handler, again, I don't want it to appear until we actually have matched data that we're going to be downloading. Otherwise, if for some reason they were able to click on it beforehand, it'll be confused because it won't have a value for raw dat matched, and potentially throw an error. So some of this is also trying to protect your user from themselves. Then we're going to use a download handler. It's got a number of different arguments, but the ones that we're going to be using are file name and content. So file name is what's going to define the name of the file that it's downloading by default. So you can of course edit it once you click download. The user can always edit it, but this is going to give them like kind of a thing to start from. And so we're going to take the name of the raw file that they uploaded. We're going to only keep the base name. So if there was a full path that they clicked through a number of folders and they had like a kind of a strange path, this will ensure that we only have the base name, so the actual file name that they uploaded. We're going to do tools file path sans ext, which means remove the extension from the file name. So it's going to remove the last .csv from the file name. And then we're going to paste on underscore fuzzy matched CSV. So in this situation where our CSV input is input.csv, it's going to become input underscore fuzzy underscore matched.csv. So it's just making it kind of a nicer, very clear that it's a different file. And then we have the content, which is a function that takes the file name, and then it's going to be expected to actually write the file. So in this situation, it's write underscore CSV. And that is the Shiny app. Let's show you how it works in real time. Let's run that. Yeah, sure, we'll save ref names. That was the update, I think, to put in a new line there. So we're going to browse. We're going to upload the input CSV. And so now you can see that this updated with the, okay, what column are you trying to match on, and what is the distance fuzzy matching you want to be using. And so in this situation, if we look back at the input CSV, we know the name column is the actual one we want to be matching on. So we can leave that, but of course there's team and performance, which were the other two columns that existed. Now we're going to upload the reference file, so the ref names.txt file, and now it will have uploaded those and read those. So it is sorting out, so you can see kind of updates to in your Shiny app back there. Okay, so we found out what the issue was. Apparently I had added in an additional requirement here, this input ref file, which I should not have done. Oh, because ref file is just a ref vec. It's not an input. It's input. Yeah. So anyway, so now that we fixed that, it was able to upload this. So we've got the name. You can select that, the fuzzy matching distance, a preview of the actual data that we've got.
Show what happens if you selected team instead of name.
If we select team instead of names, it has no idea what to do, but now it's also got this team underscore ref.
Yeah.
And we can, try to match on performance. Again, can't really match on that. But if we go over to name, it's like, yes, I can actually match on that. And then we can update the fuzzy matching, so we can see that 0.3 isn't enough, but 0.31 is now enough to have Cam Hansen Jr. match for the CMA J.
Yeah, right,
It's
right,
close
right.
enough for that. The downside is that you got to make sure that there's nobody else with a similar Cam Hansen name that is spelled differently.
Right.
And then finally, you can click download match data, and that is going to allow you to download that. And then you can get the actual data out of it. But there you go. And that is how you can approach making a Shiny app that does fuzzy matching for you. As always, thank you for joining us for 132 episodes. My name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Warrior. You can find me on Twitter at OSPPatrick. At Tidy_Explained is where the screencast resides on Twitter. Of course, it'll be us tweeting to you, not the screencast itself. It's not a chat, GPT.
Chat
Yeah,
GPT.
yeah, chat GPT. Tidy.explained@gmail.com is where you can email us. The most common way that people hit us up is liking and subscribing on the YouTube channel, dropping comments down below, and asking their questions. If you'd like to see more of this stuff, if you'd like us to continue on, I think we will, but we have some ideas for future episodes. But if you have ideas, we'd love to hear from you. Comment on the YouTube channel. Let us know what you think and what you'd like to see, or problems you're having with your own Shiny. We do have a Patreon page. If you feel like our work has impacted you positively in any way and you'd like to donate, we are thankful for that. And with that said, that's episode 132.
Thank you all so much. Keep on exploring your world.